My most favorite robot, Mars Curiosity. And the second is some famous humanoid robot. Truly speaking, I don't know the purpose of uses of that kind of robots. Okay. A robot is just for playing the violin, I don't know the purpose. Okay. The robot is playing the trumpet, I don't know. The robot, here now robot, and also Hugo. Okay. These are just playing football, doing some job, can walk, can run. Yes, as I know, in some McDonald's restaurant, some robots are uses for doing their job. But still, I am a bit confused. Why? What is the long-term or short-term benefit of building this kind of robot? But it shows the capability. Okay, making the finger, our finger is too much flexible. Our arm, we have nice 6 degrees of freedom. Okay, so building such a robot, such degree of freedom, such fingers is tremendously good job, difficult job. Okay, so if we can build this kind of fingers, that means we can build any kind of robot. We can build a robot that can do any kind of job we want. Okay, that is the most important part. That's why maybe research can be done for building this kind of robots, but application, I'm not sure yet. These are some humanoid robots who also have facial expression. Okay, this kind of research is also running for a long time. Okay, in Japan, they are building this kind of excellent robots. Recently, China also developed some this kind of robots, and I have seen Sophia, very intelligent robot. But in Sophia, intelligence is one big matter. It has an excellent facial expression. And recently, as I know, in our iLab, or under the government research fund, A2I, under A2I, iLab, they also have built an excellent robot who have very good facial expression. Again, still I don't know the application of this kind of robot. I know there are some bad applications, but I don't know some other good applications about it. But these are showing our capability, the capability of human race. Okay, that means if we can build it, we will have the ability of building anything we want. That is the point. Okay, that's showing our capability. These are very excellent robots. Okay, for guided autonomous vehicle. Okay, so if you want to carry something, if you want to carry from one place to another place, okay, by using following the line or following some rail, okay, these kind of robots are very, very effective. Okay, from one place to another place. This kind of robot even also can be used in our garment sector, like to carry dresses from one line to another line. This kind of vehicle also can be used. Okay, so I like this kind of robots. This is another interesting robot. Okay, Big Dog by DARPA, and also this kind of 4-legged and 2-legged robots are also coming from Boston Dynamics. Okay, so actually, if you see the video of this Big Dog, you will see it can go through in any circumstances. Even it's very slippery, even there is rock, even there is water. Okay, it can go through this kind of circumstances. Okay, so to carry the ammunition or to carry the food and communication module, this kind of robots are using for war. Okay, I know the application is not good, but this is another very, very interesting robot. Okay, you can see Boston Dynamics robots. Global Hawk looks very simple, but the most dangerous one. Okay, so it's also a kind of robot, but it's drive from the remote. Okay, from remote, some guy is driving this kind of aeroplane. Okay, to target some people or some place and to bomb. Okay. Truly speaking, I don't like this kind of application, but the reality is, yes, people are using this kind of devices. Okay. And these are some university project. you can see 4-legged robot or 6-legged or even 8-legged robot. This kind of robots are using for climbing the wall, for climbing the glass wall, for going to a oil tank, okay, for cleaning the oil tank. This kind of robots or this kind of things can be done. Okay, in our university, our students also build a number of these kind of robots. Okay, so but the problem is you cannot make it industrial product. Okay, a number of students from a number of universities are building this kind of robots, but these are not industry quality. Okay, so you have to take care of it so that you can build industry quality robot. Now there are some parallel robot for flight simulator or game simulation tool. Okay, these are also interesting application of robotics. Okay, and also parallel robot for milling machine. Milling machine means if you have a piece of wood, whatever shape you want, you can make the shape by using the milling machine. Okay, and also 3D. This is a simulation of the milling machine, and here 3D printer. This is also kind of robot. Okay, you can build anything you want, any mold you want, you can do it by 3D printer. Okay, so 3D printer is also becoming very, very powerful tool for engineering people, engineering student or engineering guys. Okay, so 3D printer is kind of robots, but came with huge scope of application. Okay, so this is interesting. Now let us discuss about the components of a robot. Okay, we would like to mention about 5 main components of a robot. One is mobility, like leg, arm, neck, wrist, like these. Okay, for robotics, platform also called effector. Okay, end-effector, or if it like arm or wheels, this kind of things. Second thing is perception. That means the sensing unit. Okay, like for human, eyes, ears, nose, smell, touch. For robot, sensors. Okay, to perceive the environment. Third thing is control, like processor. Okay, for control or for processor, we need 2 things. One is processing ability, and number 2 is processing algorithm. Okay, if we have good processor but we don't have good algorithm, it will not give a good result. Okay, so we need both of these things, combination of good processing, good processor, and good processing algorithm. Number 4 is power. Okay, so power is important because depend on the application. Like for our cell phone, power unit can be a bit expensive, but it should be very lightweight. But for our car, since it should be heavy duty, okay, should be cheap, okay, and the life should be a bit longer. Okay, so depends on the application. For quadcopter, again, we need very lightweight. So considering this thing, we need to make the power. What kind of power unit we are going to use. Okay. And last part is communication. Again, how one robot will communicate with each other. Okay, or how human being will communicate with the robot. So we need communication units. Okay, we need efficient communication unit for building a good robot and building a good system or digital system. Okay, so these are the main 5 components of a digital system. So for robot, we can say 3 subsystems. One is sense, plan, act. Once again, we are also doing the same thing. We sense something, then we plan what to do, and then we act for that accordingly. Like if some mosquito bites on my hand, we feel something, some itching thing, we look to it, what is it? It's mosquito. My brain take the decision what to do. If we think I'm very kind guy, we'll just say, go away from here. But if I become a bit rough guy, I will just kill it. Okay, so sense, plan, act. Now, the subsystems, as I told you, sense, plan, act. Here it's mentioning recognition, control, and motion. Okay, so in this session, we're going to discuss about motion, recognition, and control system. So, if you go to the motion, you can see there are some subsystems in motions. Subsystems of this motion subsystems are manipulator, end-effector, actuator, and transmission. Okay, this is the manipulator. robotic arm. Okay. We human being also arm of 6 degree of freedom, like 1 degree, 2 degree, okay, 3 degree, 4 degree, 5 degree, and 6 degree. Okay, so our arm is with 6 degree of freedom. So if we have 6 degree of freedom arm, then it can perform in 3-dimensional space. Okay, so we have to build such an arm so that it can work in our required environment or required space. Okay. In Mongol theory, I'm again mentioning our project. In Mongol theory, we also have the arm of 5 degree of freedom. We designed the arm in such a way, they have mentioned or they have given us some problem set, like what kind of task it have to perform. So according to perform that kind of jobs, our robotic arm was built. Okay, so according to the requirement, like we don't need to work on backside. So our robotic arm don't need to turn 180 degree turn. Okay, if it can just turn this side 90 degree, this side 90 degree should be enough. Okay, so we build or like the length of the arm depend on our application, depend on the height of the robot. Okay, so according to the application, we build the manipulator. Next, the end-effector. It's very important. Okay, end-effector means the fingers. Okay, manipulator means till this part, till the wrist. Okay, this is manipulator, like the heavy to reach in a point, a heavy arm to reach in a point, and then to perform the task. Okay, so again, according to the application, the end-effector should be like if we want to drink, then our arm, our end-effector should be like that, so that it shouldn't press in such a way the bottle will become squeezed. Okay, or not so soft that the bottle will not be grabbed. Okay, so for doing that kind of job, depend on that, we need to build the end-effector. Like in our Mongol theory project, we have to press some keys of a keyboard. Okay, so we have to make our arm just a finger-like arm so that it can press some keys. We have to take something or hold a drawer, bring it out, turn and put it again. So for doing this, we need different type of claw. Okay, we use 2-finger claw. Okay, so according to the application, we will build our robotic arm or end-effector. Okay, so here are some examples. The first one is using for cutting the stitch, and the second one actually just a mechanical idea. Okay, here are some other ideas, like one is for closing something. Okay, another one is very strongly closing and opening. Okay, another one is very simple by using very simple technology, just closing and opening. So there are some examples of end-effectors. Okay, again, but end-effector will depend on our application.